Good afternoon, everybody. Let me share my screen for you so that you can see what I'm doing. There we go. How are you? Can you see my screen?
Yes, you're live.
Okay, because I'm still looking at your screen on my Teams.
Oh, maybe it's possible. No, you're live.
I'm live?
Yes. Yeah.
Okay, then. Awesome. Then I'll get started straight away. Good afternoon, everybody, and thank you so much for joining me here today. And of course, let me also say thank you if my computer does what it's supposed to do. There we go. Thank you to our sponsors who made all of this possible. It's fantastic that there's people out there making this stuff available. So as developers, we want to work on the latest things, and we want to be able to keep our skills up to date to be able to use the best fitting technologies to solve our problems in the best possible way. And more cloud solutions come to fit this description. But there's a problem. Being able to use these technologies inside of companies is something that can take far more time than we would really like. Some larger, some older companies, they can still be really hesitant about that move to the cloud, whether that is through fear, lack of knowledge, or whatever other reason. Many developers still find themselves working on legacy in-house systems. Your code gets deployed far too occasionally, with far more effort than you'd like, and you've not really got any control over how it gets deployed. And should you ever need new hardware, it can take months before that is available to you. At a previous employer, this is exactly the position that we were in. The development team really wanted to make a move to Azure. In fact, we had a project that was screaming for it, but our ops team, our budgeting team, absolutely not. Not until you can give us a list of answers. Now, this isn't totally unfair, of course, but then what answers are acceptable in this situation? Because there are reams of research on this subject, not least of which the State of DevOps report that continually supports this move to the cloud. But we're dealing with people, and people need to know things for themselves. Just taking research doesn't always work. They need to be able to feel and see the results with their own eyes. And so, to get that data, to be able to answer those questions, and to prove just what we could do, we had a hack week. A chance for us to show what we could build in Azure in a short time frame with the whole team working together, and show the costs at the end of the week. When I say the whole team, I really mean the whole team. All of the development teams, our ops team, our product owners got involved, so that we weren't just building some tutorial thing, but we were using something that could shout to the world who we were. Hi, I'm Stacy Cashmore. I'm Tech Explorer DevOps at Omniplan in the Netherlands, and I'm a Microsoft MVP for developer technologies. I've been developing software since the mid-1990s, and the last few years I have been really focused on Azure to get my things running in the cloud from the start. So the app that I'm going to show you, it's a simplified version of one of the experiments that we ran inside of my team during that hack week. It is a simple way to get data from a static Angular site and into Azure Storage. Now, before I get started, I have a couple of provisos that I need to say, I'm afraid. One, I am using Azure DevOps to do all of my deployment for these demos, but I'm not going to touch it itself. I'm just using it in the background. Two, due to time considerations, I'm using a pre-made Azure environment for my demos, because creating resources, it takes time, and I'd rather spend that time showing you things than waiting for Azure. but I am going to go through the steps of creating these Azure resources and talk to you about some of the considerations you need to make when you're doing so. And finally, before we start, I've got a lot to get through. I'm going to be doing this at a little bit of a pace, I'm afraid, but don't worry. There's a QR link at the end, and I'll be putting it on Twitter as well, that goes to a blog post where you can follow the steps yourself and try things out, see how it works for you, along, of course, with all of the appropriate links to the documentation in MS Learn and in MS Docs. Now, that's enough of me just talking and showing you PowerPoint slides. Let's get on with some interesting stuff. Now, the first thing that I want to show you is the application itself. This is going to be the interface for our demonstration. It is, as I say, a static Angular site, and it's only got one page, and it just allows people to sign up for a book club. So in order to do that, we need to know their name, their email address, and the genre that they're interested in. This is the data we're working with. Now, this doesn't change at all throughout the course of our demonstration. Everything happens on the back end inside of our API. So let's go there next. The API, I've already created a little bit out of the box for us, and it's pretty much just a standard web API created inside of Visual Studio with a little bit of cleanup done. I've removed the weather forecast controller and the weather forecast model that you get out the box because we're not using it. And I've just added a bit of code into the startup because I'm running cross origin. I just need to make a few changes there to make sure that I can communicate. But for the rest, as it comes out the box. We have this book club sign up request replacing that weather forecast request, again with the email, the name, the genre of the user. And we have our book club controller, which at the moment is completely empty and does nothing when we call it. Let's change that. Now, the way that we're going to be saving our data is a two-step process. We are going to call our API and we are going to store our data in a queue. And then we're going to use an Azure function to read that queue and do the processing that we need to do. Why are we doing this? Well, to make our users' life better. You see, I want my user to have a really snappy website where they press a button and they get an answer and they can move on with what they're doing. When we do the processing in this demo, we're just going to be storing it in a table, but in real life, we would be checking the email, we would be performing double opt-in checks, we would be making an account for this user, all sorts of things. This can take time, and we don't want that time to affect the user. And if we get really busy, it can take longer because we're really busy and we don't want to degrade our user's experience. So we're not going to do that whilst they're online. We're going to put that in the second step. The other one is each of these steps can go wrong. It can cause an error. And I don't actually want to return an error to my user. I want my user to press a button on the website, everything's awesome, and they can go on their lives happy. I want to be the person that's upset when there's an error because you know what? I've probably caused it. I should be the one that gets upset with it. So we're going to put that on the back end, and then we can have checks to make sure if there's any errors, we can recover from them and deal with what we need to do. The user shouldn't see this. So what we're going to do first is write our data into a queue. Now, because today we're only going to be doing the writing part of this, we're not going to be reading anything out. I'm just going to make a queue helper that writes to the queue, and I'm going to make a table storage helper in the function, which only writes to the storage. So let's add that now. First thing I want to do is add a folder to keep my code a little bit neat, and we're just going to call that queue helper. And inside of there, we're going to make a class. And we're going to call that class queue access. Now, because you don't want to spend the next 32 minutes watching me do typo after typo after typo, I've got some code snippets I'm going to bring across, but we're going to build up the classes bit by bit to talk you through what we're doing. So this is our base class, and let's start with these top two using statements, Azure Storage Queues and Newtonsoft.json. We're going to need these in order to get our data into a format that we can put it into our queue. Right now, we can see that we have a wonderful squiggly line, and we have that wonderful squiggly line because we need to add some nugget packages to use this. So let's do that. We're going to search for the queues. And we're just going to install the latest stable version. And we're going to say yes to all of this because seriously, who reads this? And then we're going to add the Newtonsoft. There we go. And we're just going to install the latest version of that as well. Now, inside of our queue access, the basis of it is really simple. We have a connection string. Please do not hard code your connection strings in public. This is only for the demonstration that I have here. And then we have the queue name, which we're passing in through our constructor, which is what we should be doing with the connection string too. So the next thing we need to do is actually add our message to our queue. So let's bring over another code snippet and see how we do that. We have this task which adds a message. And the message that we're adding is just a simple object. As long as you can serialize it, we can push it to a queue. And we have 3 steps we need to take here. We need to get access to a queue client. We need to convert our message to JSON, and it has to be base 64 encoded because that is what our function is going to expect at the other end. And then we send the message asynchronously to our queue. So let's bring across the get queue client to get rid of one squiggly line. And here we have another 3 steps. We need to get access to a queue service client using that connection string at the top. Then we get access to our queue using the queue name that we pass into our constructor. And the fun thing is, this doesn't have to exist yet. We can access something which isn't available. But if we try and use something which isn't available, it's going to go boom on us. So what we need to do is add this next line, create if not exists async. And it does what it says on the tin. It checks to see whether or not your queue exists. And if it doesn't, it creates it for you. After we've done that, we can return the queue client and move on. So the next thing that we need to do is get this base 64 function into our application. So let's bring that across next. And this is just taking a string input, getting the bytes from it, and then converting those bytes to base 64. Like I say, we just need that because when a function gets triggered from a queue, it needs to have that base 64 string. It can't work with a normal string. Now the only thing that's left to do is to change our controller. We are going to bring in access to our queue access by bringing the using. That was control dot in order to bring that menu up quickly. We are sending in book club signups as our queue name. And you can see here, I have no capital letters and I have no dashes. Unfortunately, queue names can't contain capital letters or dashes. It can only be lowercase letters or numbers, which means you just end up with big long strings. No Pascal case, no camel case, no kebab case, unfortunately. And then we're going to pass the request in. Now, let's just build that to make sure I've not done anything weird. And that succeeded. Woohoo. Now we're going to push this up to Azure DevOps and see whether or not it builds and deploys for us. So let me check my pipeline. I just want to check that my pipeline's been kicked off. There we go. That can build whilst we do the next step then. So I want to move to the Azure portal now. And I want to do that because we have just created code which is going to use 3 different resources. It's going to use an app service. Think of that as the metal that your application is going to run on. It's going to run a web app. Think of that as the IIS. And it's going to use the Azure Storage account itself, of course, in order to get access to those queues. So let's create those now so that they're available. Now, in order to group everything together and make it manageable, I'm going to create a resource group as well. That's going to be the first step. So we'll click on the create button, and then we need to give it a name. So let's call it Azure.IT, and then we need to tell it where to create this group. And I'm in the Netherlands, so I'm going to be choosing West Europe. And when people first start to look at this, I've known people to get a little bit confused and think, aha, I am putting a region in my resource group. That must be the default for everything that I create inside. No, unfortunately not. If I remember correctly, this is used for the metadata for your resource group. And you have to bear this in mind because this can have compliancy implications. It might be that you need to keep this metadata in a certain location. Like I say, I'm in the Netherlands, in the EU, West Europe works perfectly for me. So we will create our resource group, and there it is available. And you may notice that was instant. And I said in my intro that I'm using a pre-made environment because this takes time. Well, the resource group is the exception to the rule. I've never had this take longer than a second or so to create. The rest of them, yeah, a little bit longer. So let's now create our resources. And the first one we're going to create is our web app. Like I say, the IIS that we're going to be running on. We need to check our subscription and our resource group to make sure it's correct. It should be, but it's not always, because we created it from inside of our resource group. And then we need to give it a name. So let's call it live demo. And I can't call it live demo. And I can't call it live demo because we have down here Azure websites.net. That is, every web app inside of Azure has to have a unique name, not just unique for you, unique inside of Azure. So let's call this live demo Azure Day. That seems to work. We're going to deploy in code, and I am coding in .NET 5 right now. Then we need to give the location. And again, see, it's saying Central US here, even though my resource group is in West Europe. And then we need to create that app service plan. Now, I love this screen when I'm playing about trying new things because I can create a web app and the app service plan in one screen. You don't need to do it as two separate steps. So let's give it a name. This one doesn't have to be unique inside of Azure, so I am just going to call this one live demo. And then we need to pick the SKU that we want. How much money do we want to spend? How much power do we need? Now, for production workloads, you get a load of options here, and they range from about 60 to 80 euros a month, 60 euros a month for the cheapest, up to a whopping 832 euros a month. I like to show this bit just to remind people that just because it's easy to throw metal at a problem if you're in the cloud, it doesn't necessarily mean it's a good idea. Throwing metal at problems just costs you extra money. So make sure that you're picking what you need in order to run your app and pick the minimum possible to save yourselves money. In the vein of picking the minimum possible, let's look at the dev test options here, because we don't want to be spending 60 euros just to be having a play about. And in dev test, we have 6 different options available to us. We have a free tier, we have an €8 a month tier, and then we have production-like environments. So these green ones where you can have custom domains, SSL, you can manually scale out to make sure your application is going to cope when you scale out. The 2 cheaper options, the shared infrastructure versions, they have much fewer options available to them, and you get a limited amount of time per day. So for the free tier, you only get 60 minutes of compute time a day. It's important to say that is not 60 minutes that your website is in the air, but 60 minutes CPU time with requests coming in. So if you're making requests that cost 6 CPU minutes an hour in your testing, then you could run this for 10 hours a day. For this demo, it's perfect, exactly what we want. So let's pick the free layer. We will review and create this, make sure that I've not picked anything that I didn't mean to, and click create. Now, Azure is going to provision those resources for us. While it's doing that, we're going to go back to the resource group. You can see nothing's created yet. This one does take time. And we're going to add that last resource that we need, which is our storage account. Now, I don't know what Microsoft has changed this week, but there's bugs in this page that there wasn't earlier on. You may notice this resource group is not the resource group that we were in. It's why it's always good to make sure that it's correct. And you might see another problem in a second when I'm adding the storage account name. So here, as you might imagine, we still have a problem. Live demo is already taken. So it's got to be unique inside of Azure again. Also, like the queue name, we cannot use any punctuation here. We just have to have one massively long string between 3 and 24 characters long, lowercase and numbers. So let's do live demo Azure Day IT. And here's the second bug on this page that's been introduced this week. Up until about Tuesday, you got a little checkbox appearing on this side of this box to say, yay, you can use this name. That seems to have disappeared, and I don't think it's deliberate. Then we need to give a region. And again, we want this to be in West Europe, if I can type. This is why I have code snippets. Now, the region that you pick for your storage account is really important for two different reasons. Number one, performance. You want your data as close to your metal as possible, which means create this in the same region as your web app. The reason for that is you have latency when reading your data from a storage account. And if you keep it inside the same region, it's probably going to be single-digit milliseconds, really fast. Certainly fast enough for most things that we need to do. If, however, your data is on the other side of the world, I have seen people demo this and have latency of tenths of a second. Depending on the amount of data you're reading, that can really degrade your user's experience. So be a bit careful here and make sure your data is where you need it to be. Secondly, like with the metadata for the resource group, compliance. In Europe, we have very strict laws about where you can keep user data. If you are asking personal data about somebody, it has to remain inside of the EU. So again, I'm in the Netherlands. West Europe works perfectly well for me here, but do make sure that your metal is in a similar place so that you don't have that degradation of performance to your users. Next, we need to pick the performance that we want from our account. And we have two options here. We have standard performance, which is cheaper but slower. And we have premium performance when you need that ultra low latency, more expensive but faster. In reality, it is ever so slightly more complicated than that, but it's a good rule of thumb to go on. Finally, we need to pick the level of redundancy we want within our application. And we have 4 options here. I'm going to go through them from the cheapest to the most expensive. And we'll start with the top one, which is this locally redundant storage. That is, on the cheapest option, we still get our data duplicated inside of one data center. That means that you're protected against rack failure, you're protected against disk failure, which I think is really cool. On the cheapest option, we still have that resiliency built in. Next up, we have zone redundant storage. I do not know why these are not in order on the screen. Zone redundant storage is where you have duplication of your data inside the same region. So that is, instead of having your data duplicated just inside one data center, it's duplicated inside many datas inside the same region. So you're protected against the rack failure, the disk failure, and even a whole data center falling out of the air. It isn't unknown for Azure to lose an entire region, though. And if that is an issue, then you can go for geo-zone redundant storage. And that is where your data isn't duplicated inside your zone at all. It's duplicated to a second region. That means that if anything happens in the primary region, you can swap over to the second one. Finally, for the critical data scenarios, as it says here, you have geo-zone redundant storage. That is, in your primary region, you have zone redundant storage. Your data is duplicated across multiple data centers. On top of that, you have locally redundant storage in a second zone in case anything happens to your primary zone. Obviously, this is the most expensive, but if it's absolutely critical that you lose no data, it is important. We also have this checkbox available at the bottom, and that is make read access available in the failover zones. That means that you can't only read the data in the second zone when a failover occurs, but you can always read that data in the second zone. For us, again, cheapest option is perfect for this. Locally redundant storage, just because I want to write and read from it and see what happens. So let's review and create this one. And that will now make me a storage account. Let's go back to our pipelines, and it's finished. So now we can come back to our book club and we can enter our first test data. So we're going to have Amy Pond. And Amy is on the TARDIS. And anybody who knows Amy knows that she's interested in 40s crime noir. So we're going to submit that. That's going to go up to our API. We're going to get access to our queue. We're going to check to see if it exists, which it doesn't, create it, and then we're going to put the data in there. So has it worked? Let's go back to our running demo. And I have this storage account here. And if I go to the Storage Explorer on the side, we can actually see the data which is in our application. Now, I meant to show you this before I did the demo because I wanted to show you that the queue doesn't exist. I can show you at least that the table doesn't exist. Trust me, the queue was also not there. We do have a queue now, though, and we have Amy in the TARDIS for 40s Crime Noir. Now we just need to process this, get it into table storage, and like I say, at that point, you're also going to kick off the orchestration for checking all of the other things as well. Now we're going to be doing this inside of a Azure function. So let's create an Azure function project. We want an Azure function. And for this, there's a few things that I need to do to ensure that my pipeline works properly. So I need to make sure that it's got the right name, because my pipeline is going to look for a name. I need to make sure it's stored in the right location so that Git picks it up correctly. And I don't want to place it in the same directory. So create this. And then we need to pick the type of trigger you want. There's lots of different triggers that you can choose from here. I suggest looking it up online. There's lots of options, lots of different connections that you can use. I do want to connect it to my storage account though, and I want to connect it to this Azure running demo, which is where all my data is going to be. I'm going to leave this connection string empty. This is one that you would use to give a name to a connection string property in your environment settings, so that when you're running this as a production workload, each function can get its data from a certain storage account. I'm not going to do that for this demo. I'm just going to be using the storage account that's associated with a function by default. And of course, we need to set it to the correct queue, and that's going to be book club signups. So let's put that one in. Now this is going to scaffold up my function for me, and hopefully it's not going to take too long. At this point, I have to start going, come on, little computer, you can do this. There we go. Ish. Almost. There we go. It got there eventually. So the first thing I want to do is rename my Azure function because I hate having function one. And while that's renamed, we're also going to rename the class. And I'm also going to rename this function name attribute here. Now, when you do this, do not use spaces inside of this name. It will build, it will deploy, it won't give you any errors, but it won't work, you won't see it, and you'll pull your hair out trying to figure out what you've done wrong. Don't be me, don't do that. What you can do instead is actually use name of here and just use the name of the function itself so that you always know it matches the class that you're deploying. Then we have our queue trigger here. I need to get rid of this connection string, the one that I said we're not going to be using, that you probably would do in a production workload again. And now we have a function which is going to be triggered by our queue. We are going to get our JSON data in, not as base64, but just as JSON data. We can deserialize it and we can move on. Then the question comes, why would I want to deserialize this myself? Because if I tell the Azure function how to deserialize my data, it's going to do it for me. So we're going to bring across this request class again, just so that the function knows what it's working with. And now if I go back into my function, I can change this to signup request. We'll call that request, since as we're calling it, since as it is a request. And my function will now deserialize this, and I have an object that I can work with and store in my Azure Storage table, which is the next thing we're going to be creating. We've got 11 minutes left, so we should be in enough time. So again, I want to make a folder to try and organize my work just a little bit. We'll call that table access, and then we're going to create a class called storage table access in order to put our code. Now this one again, it's going to look fairly similar to what we had before, only with different usings. So we're going to take this Microsoft Azure Cosmos table, and again, we're going to have to make sure that we add the NuGet package. And yep, I am using Cosmos table. Even though we're not using Cosmos DB, the API is the same. So we can install this one. This also gives us a really easy upgrade path. Should you wish to move from Azure Storage Tables to Cosmos DB, but still using the table API, you can do this just by changing your connection string. So we've got rid of the red squiggles, and this looks fairly similar to the QAccess class. We have a connection string. We have a table name, which we're passing in via the constructor. Again, connection strings, don't put them in code, don't hard code them. That's a bad thing to do. Now, as with the queue, we're only going to be writing data today, so we're only going to be coping with, not that one, that one comes in a minute. We're only going to be dealing with inserting data into our table. And to do that, we have to get our table. We make a an insert table operation from the entity that we're passing into our function, which is this table entity type that comes from that Microsoft Azure Cosmos table namespace. It's a special object that you need to use when working with table storage. And then we execute that insert statement against our table. We still have some red letters there, so let's bring across the function that I gave you a sneak preview of just 2 seconds ago, get table async. This looks remarkably similar to what we've just done with the queue. First of all, we need to get a cloud storage account from that connection string that was set above. Then we create a cloud table client from that cloud storage account. And then we get a reference to our table. And again, as you've seen in my storage account, this doesn't have to exist. So we need to call that same create if not exists async underneath to check if it exists, and if it doesn't, create it for us. This is all we need to do to insert data. What we don't have yet is a data that we're actually going to insert. So let's make an entity for that right now. We're going to put that in the same folder. And we'll just call that sign up entity. And this entity, as you can imagine, inherits from table entity. And that means there's 2 properties that we need to take care of. One is this partition key, and the other one is this row key. Partition key, how we partition our data in the storage table, and the row key is a unique row inside of that partition. So if you put the 2 of them together, you get a unique value for your row of data. Now, I don't like having partition key and row key spread throughout my code. I prefer to have something a little bit more to do with my domain, which is why I've got these ignore property attributes here so that I have genre subscription and unique name, which isn't very domain specific, but you get the idea, so that I can hide the partition key and row key from the outside world. Next up, we need the actual data that we're going to store, because right now we still don't have that inside of our entity. And again, we're just going to have the name, the email, and the genre. Now we can actually put this code into our Azure function and we can use it. So let's get rid of this log and replace this with the code that we want to use. Now, we're getting access to our storage table access with book club signups with capital letters, so it's readable, thankfully. And then we're going to insert that request. Now, the first thing here is, right now, our function is not async. We need to make that async. So let's bring that in. Second one is, we want to insert this sign up entity, but we only have request available to us. So what we need to do is bring in an adaptation to make this work. Now, of course, in real life, that's not what I wanted to do at all, is it? Let me try that one again for you. In real life, you're going to have much more production-ready code that does this. It's going to be its own class. You're going to be using something like Automapper or anything else so that you don't have to deal with it yourself. But for us, this needs to be static. But for us, we're just doing this in the simplest possible way. We get a request, we put the name, email, and genre across. We're setting the genre subscription to the genre for the partition key. And for the row key, that unique name, we are taking the name in the request. And rather than doing some really cool data collision checks, we're just going to take the ticks from datetime now to ensure that every request we get is unique. Just do a quick build to make sure that I've not done something wrong here, and then we'll push this up to Azure DevOps. And hopefully I've got just enough time for this to deploy and show you it working. So let's push that up to Azure DevOps. Yeah, that's gone through. Has the pipeline been kicked off? The pipeline has indeed been kicked off. So we have this Azure function, but now we need to create it. We need it available inside of our resource group. So let's create it now. So we're going to make a function app. We are going to check that the subscription and the resource group are correct, and then we're going to give it a name. And you've guessed it, the name has to be unique inside of Azure. In fact, it's still running under this same Azure websites.net. So web apps and functions have to be unique with each other. So live demo function app. And that one's, see, this is a little checkbox that was missing from our storage account. We need to give it a runtime stack. We're going to go for .NET 3.1, and we want to run it the same as everything else in West Europe. Now, for a function app, it's really important to check the hosting tab as well. First thing we need to do is connect it to a storage account. We're going to connect it to the one that we just created. This storage account has to be in the same region as your Azure function. If it's not, the portal won't let you pick it. Why? Because functions don't exist in reality. They only exist when they are running. And like I said, with latency and the delays in getting your data across, you don't want to be copying your entire function from the other side of the world whilst the user is waiting to be processed. We want this as close as possible to the function app. Then we're going to be deploying to Windows. Looking at the time, I don't have time to explain why I'm deploying to Windows and not Linux today. But if you are interested, catch me on Twitter later, ask me the question, and I'll gladly answer it. And then we need to pick the type of plan that we want. We have three options here. Consumption, that's serverless plan. The cheapest option, you get, I think it's 1 million invocations for free per month. So depending on what you're doing, it makes functions pretty much free. But it has some downsides. It is really cheap. It is serverless and pay as you go, but you lose some security features which can be important to you. You can't put them inside of subnets, example, to protect them from the outside world. We also have premium functions. Now, premium functions have a couple of advantages. The first one is that you always have a cold scale-out instance ready to go. So the cold startup that you get on the consumption plan when you have to copy your data to the function doesn't exist. You have a cold one. The only thing it's got to do is start up. For a premium function, it can also scale out to, I believe, something like 200 instances. So it's mega scalable if that's what you need. And you have all of the networking available that you have with an app service. So it's nice to fit inside of your whole Azure cloud native architecture and keep it secure. And then we have an app service plan, which is just an app service plan. So you have all of the same options as an app service plan. The advantage of using a function here, of course, is just that you can run many on the same app service plan because they don't always run. They only run when they're called. So it's not the same as having a web app, which is there 24/7. Again, for our demo, we're going to go with a free server list here. It fits what we need perfectly. So we'll review and create this. We'll pass it through. Then we'll check to see whether or not my pipeline's working. Okay, it may have deployed, so let's check that. This is always a tricky part of the demo. This bit takes a little bit of time, and there's generally not that much time left. So if I go in my pre-made function app, I should be able to look at the functions here, and I don't have a function, unfortunately. We'll wait to see what the pipeline does. Hopefully this will come across in a second. I really want to try and give this as much time as possible. Yeah, you may have seen deploy again. I have a problem inside of my deploy pipeline that I've not managed to fix yet, and I have to deploy twice before my function app appears on the screen like this. So now we have a function app. It should have triggered already, and there we go. And that means that if we go back to our storage account, this is the point where I need a drum roll. We have our queue, which is now empty. And now we have a table which has been created with Amy Pond inside of it, processed and ready to receive updates about that Fortis crime noir that she's interested in. Okay, let's get back to the presentation then. So what did this cost? That was one of the questions we had from our ops team and why we started this experiment in the first place. Well, keeping it simple, what I've just shown you for this talk, I've been using it since February, March last year when I first started to write this demo. I have done huge amounts of practice mistakes. I've given this talk several times. And in the last year, I've spent a total of 20 cents. This was really cheap. But of course, you'd expect this to be cheap. What about a bigger group? Well, that hack week that we had, 6 teams, all using lots of different things inside of Azure. None of us using the free tier for anything because we wanted to know what it was that we could do. So we were using machine learning, Azure Signal R services, full-blown app services so we could practice with scale outs and that type of thing. And we spent a whopping 25 euros for 2 weeks playing around with it. Now, yeah, when you're using the cloud, you do have to be careful. It can get quite expensive quite quickly if you do the wrong things. But if you use the Azure price calculator, then you can make sure you can use the minimum requirements for what you need, and you can add a lot of value without a very large bill. So play, experiment, try things out if you're not doing so already. If you're lucky enough to have a yearly Visual Studio subscription, then you get Azure credit, somewhere between 45 and 130 euros a month, depending on your subscription, every month of your subscription. Use it, because even if you make a mistake and spend huge amounts of money, and I've done this, the only thing that happens is you use up your credit, and then you can't use your account until the next month. That 130 euros that you get is also a spending limit, so you never hammer your credit card. If you're not lucky enough to have one of those accounts, of course, you can also take your own Azure subscription. If you do so, you get 12 months of selected services for free, and you get 170 euros of credit for your first month. And again, it's a credit limit. So should you do something wrong, you should be a little bit protected in that first month. After that first month, it is your credit card. Please be careful what you're doing. So now that you've seen how quickly we can get something up running inside of Azure to start this, at least the right access to get our data written in a disconnected way so that we can read it back later when we need to, go and have a play, see what you can build. Like I say, I know this was a real fast fly through, so there's a QR code on the screen now which will link to a blog post which goes through it. And like I say, with the links to the MS Docs and MS Learn. And I will be sharing the link to that blog post on Twitter after I've finished as well. I hope you enjoyed this talk. I hope you enjoy this conference and enjoy the talks that are still yet to come. Thank you very much for your time.
Thank you, Stacy. Very interesting. Yeah, there is no question, but I have some question for you.
Okay.
You said before from Linux. Why you didn't use Linux and say Windows instead?
I didn't use Linux because of a limitation with serverless app service plans and Linux inside of Azure. I'm hoping they fix it at some point. I've not tried it recently, so I might be saying something that's outdated here.
Okay.
But certainly it used to be that if you had a Linux consumption-based plan, a serverless plan, then that was the only plan that you could have in your resource group. You can't mix Windows and Linux anyway inside of one resource group, but you couldn't have a standard app service plan and the serverless service plan in the same one. Obviously, I could have just made two different resource groups, but for the purpose of a demo, I just use Windows and keep it simple.
Oh yeah, of course, because sometimes Linux is cheaper than Windows for the license of the machine. So a lot of people now understand using Linux and easier in the Microsoft ecosystem.
In a production environment, then what you're going to do is obviously just create a Linux or you're going to create an Linux consumption app service resource group and your standard resource group, and you're just going to have to split it between. But it's for convenience sake here, I ignore it.
No, yeah, of course. So. Yeah, well, we are perfectly in time. So thank you again for your speech, and thank you everybody, and see you next sessions.
Yeah, thank you very much for having me. Have fun, everybody. Bye-bye.
Bye-bye.